In this video, I will going to show you how to do the prime factorizations of the positive integer number. For example, how to do the prime factorizations of the number 32. Number one, you need to remember what is the prime numbers. The prime number is 2, 3, 5, 7, 11 is the number that is divisible by itself and not for another number. Now, I need to express a 32 number as a power of the prime number. What you have to do, number one, you get a 32 and the first prime number is 2. Now, you divide by 2, it's going to be 16. 16 is divisible by 2, you divide by 2, it's going to be 8. And you divide by 2 again, because it's divisible by 2, it's going to be 4. And 4 is divisible by 2, it's going to be 2. And then 2 is divisible by 2, and that is 1. When you stop, when you write 1 on the end. I have now 1, 2, 3, 4, 5, 2. Now, 32 can be written as 2 to the 5th power. And I create the prime factorization in powers of the prime number. 32 is 2 is the prime number and the exponent is 5. Another example, let me do another example. I'm going to erase this one to do another example. So what I have now, my new number is 1080. I do the prime factorization of 1080. Now, you do the same thing. 1080 is divisible by 2. Now, when you divide 10, you get 1080, and I'm going to do the prime factorization. Now, 1080 divided by 2, 1080, you divide by 2, is gonna be 540. And I divide by 2 again, because it's divisible by 2, is 270. And I divided by 2 because this number is divisible by 2, divided by 2 is going to be 135. Now, 135 is not divisible by 2. Then I need to know is this divisible by 3, because 3 is the next prime number. How you do that is you add the digits. 5 and 3 is 8 plus 1 is 9, because 9 is divisible by 3. This number is divisible by 3, and when you divide by 3 is 45. And divide by 3, 45 is going to be 15. And 15 divided by 3 is 5. 5 is only divisible by 5, and I get a 1. Now, I'm going to write what sounds on an 80 as 1, 2, 3, 2 to the 3rd power, and a 1, 2, 3 times 3 to the 3rd power times 5. And now I did the prime factorization of 1080. Another example. Another example, the number now is 2700. So 2700. You can do the same thing, 2700. And you start to do the prime factorization. This number is divisible by 2. You get 2700 divided by 2 is going to be 1350. And you can divide by 2 again, it's going to be 675. If you divide by 3, it's going to be 225. And you divide by 3 again, is 75. If you divide by 3, is 25. 25 is not divisible by 3. I'm going to divisible it by 5. It's going to be 5. And 5 divided by 5 is 1. And you finish. Now I have 2, 3, 2, 2, 1, 2, 3 times 3 third and time to 5. And I do the prime factorizations of 2,700. Another example. I'm going to do another example. For example, I'm going to do the prime factorization of 4356. I got a 4356. Now you can divide 4356, you can divide by 2. Divide by 2 is 2178. And as you divide by 2 is 1089. But 1089 is not divisible by 2 because this is even number. This is odd number, sorry. This is not divisible by 2. You try this is divisible by 3. Is divisible by 3 is 363. And I divide by 3 again is 121. But a 1 is only divisible by 11. 121 divided by 11 is 11. And 11 divided by 11 is 1. And I finished. Now I have 2 square times 3 square times 11 square. This is another example. I'm going to do now the last example. The last example, let me get the last example. The last example is, I'm going to do this one now, I'm going to erase it. The last example, I'm going to do the prime factorizations of 3087. 3087. I'm going to do the prime factorization. 3087. Now you see that this number is not divisible by 2. Now I need to try, is this divisible by 3? Is this divisible by 3? When you divide by 3, it's 1029. And you divide by 3 again, it's going to be, divided by 3, is 343. And now you need to try, is this divisible by 3? Now, when I do that, 4 and 3, you add the digit. 4 and 3 is 7, and 3 is 10. 10 is not divisible by 3. It's not divisible by 5. I try to do, is this divisible by 7? Now, if you divide by 7, you had 49. And a 49 is divisible by 7 again, it's going to be 7. And 7 is divisible by 7, and you get a 1. Now I have 2, 3, and I have 3, 7. And I have 3 squared times 7 to the third. And that is a way to do the factorizations of any numbers. To do the prime factorizations of any numbers. Now I have to do another example because it's important to see another examples more simples. But when you need to prove, you need to use another factors to do that. Okay. Now I'm gonna do this one now. For example, I'm gonna do erase this one. Another example is this number. We're gonna do the prime factorization of this number. 1575. This number is not divisible by 2. Now you not try to 2. I'm gonna try 3. When you divide by 3, you divide 1575, you divide by 3, it's gonna be 525. If you divide by 3 again, you have 175. But now 175 is not divisible by 3 because when you add the digits, the answer is not a number divisible by 3. Now you need to divide by 5. It's the next prime number. And 175 divided by 5 is going to be 35. And 35 divided by 5 is going to be 7. And 7 divided by 7 is 1. And now this number can be represented by 3 squared times 5 squared times 7. Thank you very much to watch this video. I will see you in another video. Have a good day.